Hello and welcome to this video on how to conduct mediation and path analysis in the free JASP software. My name is Geiser. I'm an instructor with QuantFish, and on this channel I present weekly statistics tutorials. I usually talk about multivariate statistical methods including structural equation modeling, factor analysis, multi-level analysis, and latent class modeling. If this is something that interests you, then please subscribe to this channel. Also, don't forget to check out the description for additional resources, including courses that I offer through QuantFish. In this video, I want to show you how you can run a mediation analysis and path analysis conveniently in a software that is, first of all, free, and second, very user-friendly, which allows you to use a graphical user interface, point and click, to get your mediation model set up and to get all the output by point and click. So it's totally no code and gives you a lot of the same features as programs for path analysis would, such as Mplus or LAVAAN. And in fact, JASP uses LAVAAN, the R package, behind the scenes for structural equation modeling, path analysis, and factor analysis. So it's a really great way, practical way to run LAVAAN with a graphical user interface without having to write any of the code. So let's take a look. So here you can see this is the opening screen of the JASP program. Once you download it and install it, it looks like this. It's free, friendly, and flexible, and that's really true. This user interface I like a lot. It's really intuitive. You can find a lot of the options without having to Google or having to ask somebody how does this work. It's all right there. It's like created in a way with the user in mind, as they say. And also it's very easy here to open a data file, so you don't have to worry about, oh, what format does my data have to be in. You can open an SPSS data file, or you can use text files and other files. So let's get started here and let's open a data file by clicking on this open button, and then you can see you can either select from recent files that you've already used a while ago, or you could search on your computer or from other sources where you might have a data file. So in this case, you can see I have used an SPSS data file, math.sav here, and then also I have a file already prepared that is in the JASP format, health.jasp, that I'm going to use here to show you how to conduct path analysis and mediation modeling in JASP. So let's open that. And so you can see that not only did the program here save my data file, or have the data file, which we can take a look at by clicking on edit data. So you can see here's the data file, but it also saved the analyses that I previously ran for these data. You can see I have three variables here. Physical health is my X variable, functional health is my M or mediator variable, and subjective health is my outcome or dependent variable Y. And so this is where the data are, where you can edit the data. And then when you click on analyses, again, it takes you back to that screen where you can find all the analyses options in the top menu bar, and then also you could add more by clicking here on this plus button. You can find additional options, and you can see I already ran a mediation analysis here once and a structural equation modeling analysis on this data, but I'm going to undo these to show you how this works, and I can get rid of these by just clicking the X button here to make these go away. And so then we can start over and I can show you how this works from scratch. So there are different options in JASP for running a mediation or path analysis. And so there's one really convenient user-friendly option where you click on SEM and then mediation analysis. And so here you have a point and click menu, kind of like in SPSS on the left-hand side. And so this is where you have your variable list, and then you can select variables from that list as predictors, so X variables, mediators, M variables, and outcome or Y dependent variables. And also you could include background confounders, meaning variables that you would like to statistically control for. And then on the right hand side of the screen, you already have the results section with the relevant tables that JASP has already prepared here, so that we can now select the variables, and then the values here will be filled into these tables, and we can select additional output from the options on the left hand side in the lower left hand side corner. So let's go ahead and select our variables. So physical health is my X variable here, so that would be the objective health status of a person. For example, how many sicknesses this person had in the past year, or other markers of physical health. So this will be our predictor X. And then functional health is how well a person functions in their daily lives, for example, with regard to climbing stairs, working out, working in the garden, doing physical activities, and so on. So this is our mediator variable, where we assume that physical health impacts the functional health. If I'm impaired, if my physical health is not as good, then my functional health also won't be as good. So that's the first step here. So this will be the A path from X to M that will be given here through this chain of variables. And then the outcome variable is subjective health. So this is how a person rates their own health subjectively. And so here we can then take a look at whether physical health has an indirect effect on subjective health via functional health, and or whether there's a direct effect of physical health on subjective health. And so you can see, once you have at least one X variable, at least one M variable, and at least one Y variable, you get output on the right hand side. The output is interactive, so if you added variables, then the output on the right would change, which is kind of nice because it means you don't have to rerun your analysis with a different set of variables. You have flexibility here. It's interactive. You can add variables, you can take variables away, and then immediately the output on the right hand side gets adjusted with regard to what you do on the left hand side of that screen. And so that's pretty convenient, so you don't end up with unbelievable amounts of output where you have to sift through and see, oh, what did I do here, what did I do there. It's all, so to say, limited to this screen that you see here. So you can see on the right hand side we have first of all a table with the direct effects. In this case there's only one because we have only one X variable, and so the direct effect from X to Y, physical health to subjective health, is estimated to be negative 0.095. Notice that this is the unstandardized solution by default. Later I'll show you how you can select standardized parameter estimates as well. You get a standard error, you get a Z statistic for testing the null hypothesis that the parameter, the direct effect here, or C prime path, is 0 in the population, and you can see that that null hypothesis here can be rejected because the p-value is very small for that z-score, and as a result the parameter is significantly different from 0. You also get a confidence interval, 95% for the estimate, which is also a nice feature of this output. And then next is a table with indirect effects. In this case also there's only one because there's only one mediator. And you can see that the indirect effect is negative 0.084. So that's the product of the A times B paths. And there's a standard error provided according to the delta method, as you can see here in the table note, based on maximum likelihood estimation, a z-score, and a p-value, as well as a symmetrical confidence interval for that indirect effect at the end. Now notice that this may not be your preferred way of testing the significance of the indirect effect, because symmetrical confidence intervals and conventional tests of significance are not ideal for the product of two coefficients. Remember, the indirect effect is the product of the A times B regression coefficients, and so what we prefer to do is use bootstrap confidence intervals for testing the indirect effect, and that is something that JASP also allows you to do, and I'll show you that in a little bit. Let's first go through the rest of that standard output here. And so you can see that the next thing that we get is a table with the total effects. And so here, so say the total effect from physical health to subjective health is given as the C prime path. So the direct effect in the first table plus the indirect effect A times B, which is in the second table. And so that estimate is then negative 0.179. And there's also a significance test given here for the total effect as well. And then finally, we get all path coefficients, so all direct effects A, B, and C prime in that table at the end with a standard error, Z statistic, and p-value. You can see that functional health to subjective health, that's the B path that we have not seen before. That's 0.876, and that's also statistically significant. The physical health on subjective health direct path is C prime. We've already seen that, negative 0.095. That's the same effect as in the first table up here. And then finally, we also get the physical health to functional health path here, which is our A path, and that's negative 0.096. So that's the standard output that you get by default in JASP for a mediation analysis. The nice thing is that it's all point and click, so you don't have to run multiple regression models, and it's very flexible with regard to the number of predictors, the number of mediators, number of outcomes, so you can have more different variables in here. In addition, you can select more options from the menu on the left-hand side. So you can click here and then you can request that the standardized estimates be shown instead of the unstandardized solution. So when you click on that and then you click again, or you wait a second and then you look again on the right-hand side, you can see now the estimates here have changed to the standardized solution. So you got to make sure that you are aware of whether this field here, this box has been checked or not, because depending on that, you will see either the standardized or the unstandardized solution on the right-hand side. You can also print the LAVAAN syntax. Remember that JASP uses the LAVAAN package from the R program behind the scenes for estimating the path analysis with maximum likelihood estimation or other estimation methods. And so you can print the syntax and then it appears down here in our model syntax output. And that's useful in cases where you might want to learn LAVAAN and use it, because at the end it's more flexible if you use LAVAAN syntax directly in LAVAAN, or you run LAVAAN through JASP, but you work with syntax that allows you to use a lot more options than the point and click. So it's a good way to learn the basic LAVAAN syntax and code. You can also print R squared. So when you check that box here, then there will be an additional table for the mediator, functional health, and the outcome variable, subjective health. And you can see that 39.7% of the variance in subjective health was accounted for by the predictors, and 20.4% of the variance in functional health was explained by physical health. Also, you can see that we can use bootstrapping here. We can use the bias-corrected bootstrap method for calculating the confidence intervals. And so I'm not going to do that right now, because then it'll take a long time, because running 1,000 or however many bootstrap samples will take a while. But this is an option for getting the bias-corrected bootstrap confidence intervals, which are often recommended for testing indirect effects, for testing mediated effects. So this is a good option to remember, that you can use bootstrap methods, including bias-corrected bootstrap methods, for calculating the standard errors and the confidence intervals. Furthermore, there are plots available. There is a model plot that you can look at, meaning a path diagram. You can also include the parameter estimates in the path diagram. You can include a legend in that path diagram. It takes a while for JASP to generate that diagram, and then once it is finished, it appears on the right-hand side in the output together with the other output. So this will be added. You can see it's still working on it. And in the meantime, we can take a look at the advanced options here. When you click on advanced on the left-hand side, you can see that the default method for handling missing data is full information maximum likelihood, which is also great because that way you don't have to worry about missing data. They will automatically be included as long as the participants have scores on one of the variables. Then this will be part of the analysis, and that's the method of choice. It is better than listwise deletion for handling missing data, which you could also select if you wanted to, but full information maximum likelihood is a better method. And that's actually an advantage too of using this approach to mediation analysis as compared to using, for example, SPSS, where you could not readily obtain full information maximum likelihood estimation with missing data. So this uses the LAVAAN package and uses structural equation modeling as the framework for estimating these parameters, and so therefore FIML can be easily used here. You can see that now on the right hand side we have our path diagram with the three variables. So you can check that what JASP gave you is what you wanted, and you can see the estimates here also in that path diagram. Furthermore, you could select a specific estimator. You can see that now it's set to auto, which is maximum likelihood estimation here. And there's also other estimators available, GLS, WLS, and DWLS if you had ordinal variables. If the variables weren't continuous, then you could use that. So it's actually great. It allows you for a lot more flexibility than other programs would for path analysis that are point and click, and so it's maybe one of the most convenient, we could say, programs for running a mediation model through point and click options without having to write the code. Now, that being said, it is limited in that it is a simple chain where you have X, M, and Y, and you could have multiple mediators and multiple X variables, but you couldn't have a model, for example, where you have X and then M1, and then M1 influences M2, and then M2 influences Y. So if there's a more complex chain of mediation going on where you have multiple mediators connected in a chain, then this option wouldn't work. And so then what you could do in JASP is you could go to the option SEM, structural equation modeling, which is the more general option that allows you to do also path models with latent variables, including mediation models with latent variables where you have measurement models. But when you choose this option, structural equation modeling, then you have to write the code yourself. So in that scenario, under structural equation modeling, so you have a window here where you have to paste the LAVAAN code. And so one thing that you can do then is you can at least go to your previous mediation analysis output, and you can copy and paste the syntax that we previously saved for our mediation model, and you could use this as a starting point. So we can copy that and then go back to our structural equation modeling input window, and then we could paste the syntax here under model 1. And so, of course, now this doesn't make a ton of sense because we already ran the analysis, but you could now modify it. So if you had additional mediators, for example, in the chain, you could then set up additional equations here by simply following the logic of the LAVAAN syntax. You can see that the first equation here in the syntax is the equation for y, our dependent variable with coefficient b11 and c11. So here we have our mediator, that's the b path, and then here we have our x variable, physical health, with a c path. And so functional health is the second regression equation for the mediator, and you can see that here we have the a path. And so you could, of course, extend that system of equations now pretty easily. And then also you could extend the effect decomposition here for the indirect and total effects. And so just to show you how this works, when you execute the syntax, once you're ready, you just hit Control Enter, as is stated here in the corner. So Control Enter executes the LAVAAN syntax, and then this model will be run in the same way, but now using directly the structural equation modeling option. You can see under this option, one advantage too is that you get a chi-square test here of model fit, and you have more options than you would under the more generic mediation option that we looked at before. So here we have, so say, more different parameter estimates too. For example, we get the residual variances here as well, and we can select additional output under output options. We can, for example, obtain additional fit statistics for over-identified models. We can obtain the standardized parameter estimates, R squared, and other output options. We also have more model options here, as you can see, for how to set up our model. So this is a way, so say that this is an option that is more general, that allows you to have over-identified models, model tests, that allows you to have latent variables. Also, it allows you to do multi-group analysis if you want to do a multi-group path analysis where you have different groups to compare, for example. So this option is a little bit more flexible, but it has the one, so say, limitation or downside that you have to write the syntax yourself. And so that way, therefore, so say, it is a good idea to familiarize yourself with the LAVAAN syntax for at least the model statement in LAVAAN. On QuantFish, we offer a course, LAVAAN for Beginners, that you can where you can learn how LAVAAN works in more detail. We also offer a bunch of other courses that use LAVAAN for structural equation modeling, so feel free to check that out as well. I hope you found this video useful to learn about how to run a path and mediation analysis in the free JASP software. Please consider subscribing to this channel and don't forget to check out the description for additional resources, and I'll see you next time.